So now let us see this problem. It is a minimization problem and we have 4 constraints. First, second, third, fourth constraint. But we have to make the constraint as less than equal to. So we are just लास्ट 2 constraints नॉन नेगेटिविटी की थी, उसको माइनस से मल्टीप्लाई करके सबका साइन लेस देन इक्वल टू राइट हैंड साइड में 0 बना दिया. So we have 4 constraints. That means we will have 4 lambdas and the lambdas would be non-positive because we have a minimization problem and these inequalities are not in favor for minimization. So the lambdas would be not in favor. So first we make the KKT conditions, that is lambda 1 into G1 is 0. So lambda 1 into G1 is 0, lambda 2 into G2 is 0, lambda 3 into G3. G3 के लिए क्या होना चाहिए था, माइनस ऑफ x1 मल्टीप्लाइड माइनस से 0 को कैंसिल कर दिया उससे. The last is lambda 4 into x2 is 0. So these are the conditions, first 4 conditions. The lambdas पे condition क्या है, they are all non-positive. Now we get to the gradient condition. What is the gradient condition? The gradient of z is equals to lambda 1 times gradient of g1 plus lambda 2 times gradient of g2 plus lambda 3 times gradient of g3 plus lambda 4 times gradient of g4. What is gradient of z? Minus 2 and minus 1. What is gradient of g1? 1 and minus 1. What is gradient of g2? 2x1 and 2x2. What is gradient of g3? It is minus 1 and 0. What is g4? 0 and minus 1. So let's write this. To simplify these two coordinates, you get the value from the first coordinate as minus 2 is equals to this. From the second coordinate, you get this. So these are all the conditions that are needed, equations and inequalities to get to a KKT point. Now we club them together and try to solve them. So how many cases would be there total? We have 4 lambdas. For every lambda, we will have 2 cases. So in all, we would have 2 to the power 4 cases. That means a total of 16 cases. But first, what we will check that case for which the lambdas for the non-negativity constraints are 0. Lambda 3 को 0 मान लिया, lambda 4 को 0 मान लिया, क्योंकि ये दोनों इसके लिए आए थे. And lambda 1, lambda 2 are non-zero. So if lambda 1, lambda 2 are non-zero, using this, if you see these two conditions, इनमें से ये bracket को 0 होना पड़ेगा, क्योंकि lambda 1, lambda 2 का भी non-zero माना हुआ है. So if you solve this bracket, see, इस bracket से क्या मिल रहा है? That x1 minus x2 is 0. और नीचे से क्या मिल रहा है? That x1 square plus x2 square is equals to 4. Solve this, you get x1 equals to root 2. So this implies x2 equals to root 2. But there is one more root of x1. x1 can also be minus root 2. So this implies x2 is also minus root 2. So you have x1 as root 2, x2 as root 2, or x1 as minus root 2 and x2 as minus root 2. But this point is violating this constraint. क्योंकि ये constraint है क्या actually में? It is x1 non-negative, but x1 का value कितना आ रहा है? Negative. So this point is not a feasible point, but this point still can be. So we'll find all the lambdas. Lambda 1 निकाल के देखते हैं, lambda 2 निकाल के देखते हैं. So this is an infeasible point. Now to get the value for lambda 1, lambda 2, what you do? You solve these two conditions. Lambda 3 and lambda 4 are 0, so this goes. x1 का value root 2, x2 का value root 2 put करेंगे. So you will be left with 2 equations and 2 unknowns. Solve for lambda 1 and lambda 2, you get lambda 1 as minus half and lambda 2 is minus 3 by 4 root 2. This is a point जो आपने अभी निकाला है. This is a point that is satisfying each and every constraint. Lambda i इसको नॉन पॉजिटिव होना पड़ा था, तो lambda 3 0 है नॉन पॉजिटिव, lambda 4 0 है नॉन पॉजिटिव, lambda 1 is minus half, so non-positive. Lambda 2 is non-positive, it is minus 3 by 4 root 2. So lambdas की सारी conditions satisfy हो रही हैं. x1 is root 2, x2 is root 2 satisfies all these 4 constraints. So this is a KKT point. So this is a KKT point and this point is also sufficient. यानी कि ये point बन जाएगा global minima. क्यों? Minimization problem के लिए sufficient condition क्या होती है? कि Hessian of Z must be either positive definite or positive semi-definite. What is the Hessian of this? 0, 0, 0 and 0, which is in fact positive semi-definite. All the principal minors are greater than or equal to 0. Delta I are all non-negative for all I. And a more simple way to think of it is a linear function in the variables is always a convex function. So Hessian आ गया positive semi-definite. Now this is a linear constraint. This is convex. This function is convex because इस function का Hessian क्या आ रहा है? 2, 0, 0, 2. D1 is positive. g2 is 4, that is positive, so this function is strictly convex. This is a linear constraint, convex. This is a linear constraint, this is also convex. So all the inequalities, यानी कि जितनी भी constraint थी आपकी gi less than equal to 0 for all constraints are convex, and the Hessian of your objective is also positive semi-definite. This implies this point is not only a feasible point, this is in fact a global optima, and that to a global minima. So what is the objective value at that point? Minus 2 into x1. x1 is root 2. Minus of x2. x2 is root 2. So that gives you minus 3 root 2 as the optimum value. And what is the point of optima? It is root 2 comma root 2. So that is it.